Hello everyone, welcome to the Go Code Snippets channel. So this channel is all about the Go programming language. If you are new to the channel, make sure you subscribe. And also after watching the video, if you like the video, make sure you leave a thumbs up and also ring the notification bell so when I release new videos, you'll be the first to be notified. So today we'll be talking about recursion in Go. And recursion generally in programming is a function calling itself. So in a way that function never closes. So what I mean is that, so let's say I have a function foo. So I'll declare a global variable here, var count. So what foo does is it increments count, and then it prints count. Then foo just calls itself. So that's what foo does. So if I call foo in my function and I run the code, import font. Oh, that's too fast. Let me put a sleeping mechanism. So I'll just import time. So let me just sleep it for about a fifth of a second. So time to sleep. So that's, I'm flipping it for a fifth of a millisecond. So let me run it this time and see what it gets. Or a fifth of a second rather. So that means for every fifth of a second we're having, so the thing is foo increment count. So we get a number first, let's say 1, then it prints 1, then it sleeps, then it calls foo again, then it increments counts to 2. So count keep on. So this function will run forever. So it's like running a for loop, an infinite for loop. So that's what recursion does, unless a condition is given for it to break, just like a for loop. So generally recursion is not usually a best practice, because most of the things that you can do with recursion you can do with a for loop, but there are sometimes that recursion is just the only way or the best way to go about things. But without that, it's advisable to always use a for loop as far as you can use one, unless you have no choice than to use recursion. So that is that. So the next thing is that we'll be seeing 3 different functions that implement recursion. So the first function is, let me stop this code. So the first function is a factorial function. So I'll just define a factorial function. Call it for factorial x, then it will return an integer. So when you are dealing with recursion, to ensure that the function will actually close, you have to give it a break condition. So factorial will be giving it if x equals to 0. So you just want it to return 1. Because what factorial does is, if I'm looking for a factorial of a number like 5, so what I want to do is I want to do 5 times 4 times 3 times 2 times 1 then times 0. So when it gets to 0, because 0 factorial is 1, so if x gets to 0, we just return 1. Then from here we just return, so the condition that will be executing every time the function is called, if x is not equal to 0, will be x multiplied by the factorial. So I'm calling factorial again, and I'm calling it on x minus 1 this time. So what we are just doing here is just basically, if I input 5 for example, so I'll be having 5 times factorial of 4, and factorial of 4 is 4 times factorial of 3, and factorial of 3 is 3 times factorial of 2. So we're having 5 times 4 times 3 times 2 10 times 1. Then when we get to times 0, instead of having factorial of 0, we just return 1. So the function breaks at this particular point. So this is the break condition for the function. If this condition is not there, this one keeps running into a negative number, which will not make our results accurate. So let us just call factorial. So I can just print out factorial 5. So factorial of 5 should give us 120. That's 5 times 4 times 3 times 2 times 1 times 0. So I'm having 120. So that's nice. So I would like to re-implement this factorial function with a for loop. So I can just say factorial by loop. So this one takes in x and returns an integer. So what I'll just simply do is I'll just define a variable factor, and initialize it to 1. And I'll say for x greater than 0. That means while x is greater than 0 for people that are familiar with languages that uses while loop. So I'll just say factorial should be equals to factorial times x. Then I'll decrement x each time the loop is called. And I'll simply return the fact variable. So let's see if this also works. I'll change this to factorial by loop 5. So this should work. Unless there's a mistake somewhere, but this should work. And 120, so it is working. So that is the first function. And the second one is the sum of first natural numbers. So that one is also the same thing. Sum of first natural numbers. Let's say I want to find the sum of the first 5 natural numbers. So I want to do sum of 1 plus 2 plus 3 plus 4 plus 5. This for 10, 1 plus 2 plus 3 plus 5 plus 6 up to 10. So that one is also the same thing. The base case we'll be using here is, so we want to add the sum of the first natural number. So if x equals to 0, we'll just simply return 0 instead of 1. So what I'll just be doing is I'll just be adding x plus factorial x minus 1. So if I want to add, so I'll just say sum of. So if I want to add the sum of the first 5 natural numbers, I'll just be having 5 plus 4 plus 3 plus 2 plus 1. Then when it gets to 0, it will just return 0. So I'll have plus 0. So let me run that. So I'll say sum of first natural numbers. So sum of the first 5 natural numbers. So that should be 5 plus 4 plus 3 plus 2 plus 1. So that should be 15. If we are right, unless there's a mistake, but it should be 15. It should be having. Yeah, 15. So that is it for us. So if we want to do this by loop, it's also the same thing. So we'll just simply change this one to plus. So I can see by loop. So we can initialize it to 0 instead. So yeah, 0 instead of 1. So if I run this by loop this time around, so we're having 15, so it is correct. So the third function we'll be talking about is a Fibonacci function. So to run a Fibonacci function by recursion, so in Fibonacci functions there are 2 base cases. So the way Fibonacci function works are the first number will be a 1, second number 2 will also be 1, and the third number will be 1 plus 1, 2. So the next number will be the sum of the number before it and the sum of the last 2 numbers before it. So I'll be having 1, 1 as the first 2 numbers. Then the third number will be 1 plus 1, which is 2. Then the fourth number will be 2 plus 1, which is 3. And the fifth number will be 3 plus. So that's how Fibonacci functions work. So we have 3 base cases. So I'll switch over x. So in case, so if x is 0, is 0. So if x is 0, I'll return 0. And if x is 1, I'll return 1. Then the default case will just be, so I'll return Fibonacci x minus 1, that's the number before, and Fibonacci x minus 2. So that is the previous number and the last two numbers. So the one before it, if I'm allowed to use that English like that. So I'll just get the Fibonacci. Let's see what Fibonacci 10 gives us. I know for sure that Fibonacci 10 is 55. So let's see Fibonacci 10. So Fibonacci 10 is 55, correct. So to do Fibonacci by loop is Fibonacci by loop. So what I'll just do is that in this case, this one is a little bit tricky, but it is simple. So let us go. So I'll first initialize two variables, a plus b. So I initialize them to 1 and 0. That's the first thing. So for x greater than 0, so remember this condition here is just to update our for loop. So what I'll just simply do is for each iteration in the for loop, I'll be assigning a and b to new variables. So a and b will be equals to b, a will be equals to b, then b will be equals to a plus b. So that's what we'll just do. I think it should be 0 and 1, not 1 and 0. If I change it, so if so yes, this should be it. So I'll just return at the end of the function, I'll just return a. So if I do Fibonacci by loop of 10, so it should be having 55 unless there's a mistake somewhere. 34. Why is it 34? A, B. So it should actually be 0, 1. Let's see. It should be 0, 1, not 1, 0. Yeah, 55. So actually be 0, 1. So what I'm just doing is that by initializing a and b, so what we are doing is initially we are having a to be 0 and b to be 1. So we just, as the loop runs the first time, we'll be having a to be 1. So 1 will be returned for this place. But instead of 1 to be 1, we'll return 1. Then b will be a plus b and a plus b. So b will also be 1. Then on the next iteration, a will become 1 again. Then b will be 1 plus 1, which is 2. Then on the next iteration, a becomes 2. Then b becomes 2 plus 1, which is 3. So that's how we'll be getting everything till we get to